Take 9. Oh, this is 10, I can't remember. Hello everyone, my name is Henry. I am the design director on FRC team 4512. What today's video is we're going to be going over is from scratch what is computer aided design and what it can be used for in the scope of FRC. And if you've never used a CAD program before in your life and you want to learn, this is a good place to start. So basically what we're going to be going over today is why CAD is so important in FRC and why it can be such a powerful tool that accelerates your robot game exponentially. So what is CAD? Well, it is computer-aided design. In the simplest way I can explain the program is you yell at your computer when it blue screens and does not have a recovery file after working on a part for 3 hours. But in all seriousness, it is a program that helps you take an idea from a mechanical or moving mechanism or just a 3D object, whether simple or complex, that's in your mind, and helps you give it actual dimensions in a virtual sense to where you're not spending extra time and money and paper and all that, and you sort out all the small little details and you get all of your dimensions and you create the most complex designs you ever could imagine without having to rip your hair out at math you never wanted to learn. Now, you will have to know some math, but we're not going to get into that yet. We're going to drop the math in later, just as a streamline when we get into our more complicated series about building gearboxes and all that. So, I'm going to go over the main menu of Solidworks here. So, we have Open New. We're just going to go over these two little functions for now. And Open, and then New, and then Home, and then File, View, Tools, Help. Excuse me. So we're going to create a new one. What you're greeted with when you've never used SolidWorks before is you're greeted with part, assembly, and drawing. Now we went over part, assembly, and drawing in the part numbering video, but we didn't go into detail about what they are. A part is a single body or 2 or 3 bodies that might be conjoined or separate that can go into an assembly. So in a part with another part creates an assembly. And a drawing is a 2D version of a part that gives relative dimensions and not relative, critical dimensions on the object itself that can be used for a machinist to machine. SolidWorks has its own set of custom file types that it's used to save files and can only be opened by SolidWorks. They're good because they have all of the information that's pertinent for SolidWorks in SolidWorks, so that if you saved, let's just say, a SolidWorks add-on like sheet metal. The sheet metal, the K-factor, everything about that part would be saved in that file and can be reopened with all of the critical dimensions and other things about it without anything changing. Now, there are more standardized file types like a .step file, which a .step file can be used across multiple programs, and it's really powerful as well. And then there's like an STL, which is a mesh of something. The STL is typically used for 3D prints. We commonly use it in Cura. That's, I believe, the file type it takes. I'm pretty sure. It might take steps too, I just don't know. So yeah, those are the general files. We can get into different file types more. But then there's 2D parts like a drawing file and a DXF file, which can be used on water jets, laser cutters, lots of things. So typically when a sponsor or someone who makes parts for us goes, hey, we'll love to do these parts for you, but we need this file format, how many, the material. So you can save a lot of those file types straight off the CAD without having to do anything too special, which is great, which is so powerful. Like, I know Fusion has a little loophole through to get a DXF off of it, but SolidWorks is a little bit more straightforward and all that. And we'll get into that later when we start going into water jet cut parts and sheet metal parts. But for now, just know that they exist. So now that we're in this part, we see part 2. There's a feature tree, sketch, evaluate, MDM dimensioning, SolidWorks add-ins. So there's different add-ins like CircuitWorks, Photo, 3D Preview, SolidWorks Motion, Routing, Simulation, Toolbox, Analytics, Flow, Simulation. There's tons of powerful tools that you can use and that are just great. So like you can render parts, choose all of the views you want, options, all of that. And then my most favorite, the CAM package. Now it's the same CAM package that's used in Fusion 360, and it is fantastic. I've had just nothing but good things to say about it. It's quite easy to learn, coming from teaching myself how to use the CAM package with help from some people from other teams on Toolpaths and stuff. It was a good experience, and we will be going into how to CAM stuff as well. Obviously, I am nowhere near an expert, but for a router, I think I've got it kind of dialed in. Too many parts were made on the router this year. Too many. So, in CAD, you're going to be messing with mainly your sketch features, evaluate, so getting critical dimensions, maybe simulations depending on what you need to do. If you want to lighten parts, if you want to do some other things, you're like, okay, how can I optimize this? Simulations is a great tool to do that. And then to make the parts, Solidworks CAM, let me tell you, it's a magical thing. So on the far left hand side, you can see the part tree. You can see that the planes, you can see the origin of the part, the history, sensors, material, not specified, and then you can just see the main name of the part and all that, and there's properties, configurations, all those lovely tabs that you can look up what they do and how they work, so you can see there's some CAM stuff on the far end. But yeah, we're going to focus on mainly this tree right here. So when you create a part, you typically start with a 2D sketch, and any shape and dimensions you can think of, you can make it. We'll be going over how to dimension sketches advantageously and how to create those sketches to create a 3D feature or part later on, but know that it's an incredibly powerful thing to create a dimension-driven sketch that you can change later, as well as there's scripts that you can do to create patterns, and this program is infinitely more powerful if you try to use it to its full advantage. It is insane the amount of things you can do. Then features, there's lots of cool features: loft, boundary cuts, linear patterns, circular patterns, ribs, draft, shells, wrapping, and all of these fun little names, but they all have a very powerful tool behind them that would take, I don't know what kind of math to figure out. I don't want to think about it, but it does it all for you without too much fuss, and it's quite great. So yeah, and then in the general file menu you have options, edit, you can see there's some undo, control Z of always, and then at this top bar here, these are your like quick ones. So rebuild just redoes all the math. This is one that you can use a lot, even if you're like creating a block. Let's just do that really quick. And I select the top plane, yoink it, and I'm going to go to the top plane here, and then I'm just going to go features, extrude, no particular dimension, create a block. You can redo the math, but if they're like you had a lot of complex features, it doesn't always redo all the math, and it can slow down your part and create problems. So if you do a rebuild, especially in assemblies, it can help performance and stuff. I know that was a terrible example. But yeah, mainly in assemblies, rebuilding parts is really good. Selection tools, other things, saving as, save all, fantastic tools to use. This one you're going to get used to. Make sure that anytime you do a change, you save that part, because the blue screen of death sometimes jumps at you like nothing else. It hurts so much. But yeah. And that's about it. I think that's it for today. Basically go through the menus. You can look up what they do with the little help menu. You can see about all of the different things. Search up what all the things do, and just get used to SolidWorks, get used to the different page layouts and how it all kind of meshes together and how to pan through the menus. And that's incredibly useful to get used to. We'll be going over sketches and actually no, we won't be going over sketches. We'll be going over gestures, customization and layout of SolidWorks, because everyone likes to do their own layout, whether like certain key bindings, macros, gestures, certain things. But yeah. When I say gesture, I know I haven't gone over this. It's this tool right here. So basically, you use your right mouse click and you hold it, and then you can slide up to the view. So my gesture right here is for viewing things. And so I can change the view. As you saw, the origin was moving around there while I was doing that. So yeah. that's what a gesture is. So you can gesture to a dimension, or when you're in like a sketch, you can gesture to dimension things, or you can gesture to create a line or a circle, those kind of things. So yeah, that's about it for today. Thank you all for watching. Thank you to the sponsors that keep this education possible. If you liked the video, you know what to do. If you didn't like the video, you know what to do as well. If you have any questions, please post them in the comments section. I will try to get to you as soon as possible. I do read all of them, as as weird as one of them was. If you want to look at our store to buy some merch, you can do that. Link is in the description, as well as probably right on the screen. You can also email me if you have the questions at the Otter Chaos email, which is going to flash on the screen. Have a great day, and tomorrow's video is going to be dope.